Welcome to a lesson on expressions and equations. Let's begin by defining an expression and an equation. An expression is a mathematical phrase that can contain numbers, variables, and operators such as addition, subtraction, multiplication, and division. An example of an expression with a variable is 5p minus 2. Notice for an expression, we do not have an equal sign. An equation is a mathematical sentence that sets two expressions equal to each other. An example of an equation is 3x plus 7 equals 2x plus 12. An equation always has an equal sign. Let's look at some examples. Here we're asked to consider the expression negative 3t plus 12, and then we're told to use the value for the variable given below and evaluate the expression. We are first given t equals negative 2. To evaluate the expression when t equals negative 2, we substitute negative 2 for t. If we substitute negative 2 for t in negative 3t plus 12, we have the expression negative 3 times negative 2 plus 12. Again, notice how we substituted negative 2 for t. And now we evaluate the expression. The next step is to multiply. Negative 3 times negative 2 is equal to positive 6. The expression simplifies to 6 plus 12. 6 plus 12 is equal to 18. So now we know the expression negative 3t plus 12 is equal to 18 when t equals negative 2. Next we're given t equals 5, so again we substitute 5 for t in the expression, which gives us negative 3 times 5 plus 12. And again we now simplify the expression. Negative 3 times 5 is equal to negative 15. Negative 15 plus 12 is equal to negative 3. The expression negative 3t plus 12 equals negative 3 when t equals 5. Next, we are asked to write an equation that models the truth statement for the given values. Remember, an equation is when we set two expressions equal to each other. So the equation that models the truth statement when t equals negative 2 is negative 3 times negative 2 plus 12 equals 18. The expression on the left, which is what we get when we substitute negative 2 for t, is equal to the expression on the right, which is 18. The equation that models the truth statement when t equals 5 is negative 3 times 5 plus 12 equals negative 3. Again, these are both equations because we have two expressions set equal to each other. And now let's look at some equations. We're asked to state a value or values for the variable that make the statement true, then state the reasons that make you feel confident you have found all the possible values of the variable. Use complete sentences. The first equation is u plus 5 equals 11, and again we're asked what value of u makes this statement true. Looking at the equation, we want to find a sum that's equal to 11, and because we know that 6 plus 5 is equal to 11, if u is equal to 6, we have a true equation or true statement. So we'll say the statement is true when u equals 6. There are no other values of u where the sum would be equal to 11, and therefore we have only one value of u that makes this true, or we can say satisfies the equation. And now we need to give a reason, and the reason is because 6 plus 5 equals 11. So we will say we know u equals 6 is correct because 6 plus 5 equals 11. The next equation is p plus 7 equals p plus 4. Well, we know the value of p is the same here as it is here. On the left we're adding 7 to p, on the right we're adding 4 to p. So there's no value of p that's going to make the expression on the left equal to the expression on the right. To make it even more obvious, let's write 7 as 4 plus 3. So an equivalent equation would be p plus 4 plus 3 equals p plus 4. And we know that p plus 4 must equal p plus 4 for any value of p. So writing it this way shows that p plus 7 is always 3 more than p plus 4. So to answer the question, we will say there are no values of p that make the statement true. We can also say the equation has no solution. For a reason, we will say that p plus 7 is always 3 more than p plus 4. And now for the last equation, we have a minus 5 equals a minus 5. Notice whatever value we select for a, if we subtract 5, the left side of the equation will always equal the right side, and therefore we can say the statement is true for all real values of a. And for the reasoning, we will say that a minus 5 is always equal to a minus 5. We can also say that this equation has infinite solutions, or we can say this equation is an identity because the left side is always equal to the right side. I hope you found this helpful.